Hello everyone. So today we are going to solve a new PDF problem. Okay, Pushdown Automata problem. So yesterday we saw one problem. So today we are going to see another problem in the Pushdown Automata. Okay, so we'll quickly go into the question. So obtain a PDA to accept the language. So what the language says, a to the power of n followed by b to the power of n such that n is greater than or equal to 1 by a final state. Okay, we need to write a push down automata, so that going to accept a to the power of n and b to the power of n. So here we want to consider two logics. One is a to the power of n, b to the power of n means the number of a and the number of b should be equal. That is the first condition. Okay, and second condition is it should start with a, take all the a inputs and then follow the b inputs. Okay, so these are the two conditions we should take. So they're telling a to the power of n and b to the power of n. We'll take like a to the power of 3 and b to the power of 3. Means we'll have three inputs. It should accept, the machine should accept three inputs a and again three inputs b. Okay, and it should be always equal 3 and 3, 4 and 4, 5 and 5. Okay, so before solving the problem, just we'll try to analyze the logic behind it. Okay, the same way what we did in the previous problem. First we'll analyze the stack logic. Okay, so initially the stack will be empty, so the stack will be empty. So we denote the empty stack with a z0 to make sure the stack is empty. The top of the stack is filled with a z0. So whenever it is filled with a z0 top of the stack, it means the stack is empty. Okay, so first what we'll do, whenever we read the a inputs, we'll keep on pushing to the stack. For example, a to the power of 3 means we'll receive the first a, we'll push into the stack. We'll see the second a, we'll push into the stack. We'll see the third a, we'll push into the stack. Okay, so once whenever we see the a input, we push all the a's into the stack. Then whenever we saw the matching b for each of the a, then we'll pop it. Whenever we see the first b, we have a matching a, we'll pop it. Same way, whenever we the second b, we have a matching a, we'll pop it. Same way the third b, we have a matching a, we'll pop it. Okay, so there is no more input and there is no more element to pop out because this is an empty stack. So if there is no more input and there is no more element into the stack, then it means our input is a correct input and our PDA going to accept the input. Okay, so let me now do the same problem in a transitions of PDAs. Okay, so already we know, so our PDA transitions have three things. One is state, input and the stack. So we'll start like this. We'll start with the first transition, that is Q0. So A is the input and we have an empty stack. Okay, once again I'll repeat, this is the state, this is the input and this is the stop of the stack. So our first initial state is Q0 and our input is A input and our top of the stack is Z0. So whenever this is the case, we are going to stay in the same state Q0 and we are going to push this A on the top of Z0. That is, the top of the stack is A and below that we have a Z0. So this is the first transition. Okay, so now we'll go into the second transition. So we have a Q0 and we have a is the input and A is the top of the stack. That is the second case. First case is there is an empty stack. The second possibility case is already we have a. So then also we'll be in the same state, that is a pushing state Q0. Already we had a and the top of the stack is A. Okay, now the third case is B. Whenever we are in a Q0 state and our input is B and we have a matching A. So then we want to do the popping. So whenever it is a pop logic, we'll say Q0 will do the, our transition will transfer from the Q0 to Q1. Whenever we have a pushing logic, we have considered the Q0. Whenever we have a pop logic, we'll come to Q1. So Q1, we are going to pop the top of the element. So whenever we pop, it means that the top will be empty, that is epsilon. Same way, again the same logic, that is the first time. Now we are already in the pop logic, that is Q1 state and the top of the stack, the input is B and the top of the stack is A. Then also we should same in the same state, that is pop, that is Q1, and we want to make the, remove the top of the element, that is epsilon. Okay, so these are the condition. Then last transition is this, we are in the same state, and epsilon. Epsilon means there is no more input to pass, and you are in epsilon, and you are the top of the stack is Z naught. Okay, then we go to the final state, that is Q naught, and keep the Z naught as it is. Top of the stack, keep the top of the stack as it is. Okay, so therefore our machine stops at this condition. Okay, so these are the transitions for the given question. Now we'll see how to draw the transition diagram for the pushdown automata. So we have a first state is Q naught state. So we'll take that one. So we have in the Q naught state. Okay, then we want to go to the Q1 state. So we'll draw that one also, Q1 state. And again we have Q2 state. So we have a Q2 state, and we know that Q0 is the first state. So denote with the input arrow. So Q2 is the final state. So you double circle that denotes the final state. Okay, now we'll start connecting each transition. So from Q0 to Q0 itself, we have a Z0, and our output is a Z0. So you do the self loop. So self loop, the first transition says we have a input, comma, the top of the stack is Z naught, and our output is a Z naught. Okay, this is done. So we'll go the second transition, that is a comma a, that is a. So you can say like this, a comma a, it goes to a and a. So that is between Q naught and Q naught. Now this one is third transition between Q naught and Q1. So you should draw a connection, Q naught and Q1. Between Q0 and Q1. So if you have B and the top of the input is, top of the stack is A, and it's going to be popped up. So that is B comma A will be changed to epsilon. Okay, that is between Q0 and Q1. Now again Q1 to Q1. So again you draw the self loop for this transition, that is Q1 on Q1. So B comma A will gives you epsilon. You write that one. So it's B comma A such that the output is epsilon. Then final logic, that is Q1 to Q2. So you draw a line from Q1 to Q2, and you say epsilon comma Z naught. Epsilon was the input and Z naught is the top of the stack. It becomes keep the Z naught as it is and go to the final state. So this is the transition diagram for given pushdown automata. So thank you for watching. Subscribe and like for more such videos.